Hello everyone, welcome to the Electron Flow Academy. So today we are going to discuss about the numerical problem number 3 based on the RLC circuit. Okay, so the question is given to us is a coil of a power factor of 0.6 is in series with a 100 microfarad capacitor. Okay, so this is the condition given us in the question when connected to a 50 hertz supply. Okay, so the frequency of the supply is given to us, which is 50 hertz. So the voltage across the capacitor is equal to the coil. So one condition is given to us in the question that the voltage across the capacitor is equal to the voltage across the coil. Okay, so here the coil meaning is the series connection of resistance and inductance. Okay, so in this question the question is asked us is that to find the resistance and the inductance of the coil. So the two parameters in this question we have to calculate. Okay, so first one is the resistance of the coil and second one is the inductance of the coil. Okay, so let's draw the circuit of the given question. So circuit will look like this is our resistance and this is the inductance. Okay, so I am denoting resistance as a capital R and inductance is J of XL. Okay, so this is our coil. Okay, so this area is our coil. If I highlight this area, so this is the coil. Okay, so next thing is that so a capacitor is connected in a series. So this is the coil, and in the series with this coil, there is one capacitor is connected. Okay, so value of the capacitance we are assuming here negative of J of XC. Okay, and this load is connected across supply. Okay, so this is the AC voltage source. We are assuming that V volt because the voltage is not given to us. Only one thing is given to us is that the supply frequency, which is 50 hertz. Okay, so the question in the question there is one condition which is the voltage drop across the coil. So I am assuming here the voltage drop across the coil is VL. Okay, and the voltage drop across the capacitor is VC. There is one condition given to us that the voltage drop across the capacitor is equal to the voltage drop across the coil. Okay, so let's calculate values. So here firstly the value of the capacitor given us to is 100 microfarad. Okay, so we can calculate the capacitive reactance. Okay, capacitive reactance is X of C. We know that the X of C is equal to 1 upon omega F, meaning 1 upon 2 pi F C. Okay, so X of C is equal to now 2 into pi into 50. Frequency is 50 given to us and multiplied by the value of the capacitor. So the value of the capacitor given us to which is 100 micro meaning 10 to the power minus 6 farad. So after solving this, I get the value of X is 31.83. The unit is ohm. Okay. So firstly, I have calculated the value of XC. Okay. Next thing is that the voltage across the coil. There is another thing. Voltage across the coil, which is denoted by here VL. Okay, so value of the voltage across the coil is current multiplication with the impedance. Okay, and the voltage across the capacitance and the voltage across the capacitor is equal to Vc, which is equal to I times X of C. Okay, so here the condition is given to us in the question. The voltage across the capacitor is equal to the coil voltage. Okay, this is the condition. So from this condition, I can rewrite the equation is Vc is equal to VL. Okay, so from this condition, I can return Vc is equal to VL. Okay, so let's put the value like here Vc is equal to I times of Xc, which is equal to I times impedance. Okay, so from here we can see that the current is cancelling here. So the formula is now equal to Z is equal to X of C. Okay, so we have calculated the value of the Z. Okay, because the Z is equal to the Xc. Okay, so we have the value of the Xc, which is 31.83. So the value of the impedance is also equal to 31.83 ohm. Okay, so now firstly we have calculated the Xc. Okay, this is our Xc and this is our impedance Z. Okay, next thing is that here we know that the power factor cos phi is equal to the ratio of resistance to impedance. Okay, so from this expression, because we are using this expression because the power factor is given to us and we have calculated the value of Z. So from this expression, we can calculate the value of resistance. So R is now equal to Z multiplied by cos of phi. Okay, so resistance is equal to now impedance is 31.83 and power factor, which is cos phi, given to us is 0.6. So from this expression, the value of the resistance of the coil is equal to 19.01 ohms. Okay, so here we have also calculated the value of resistance. Okay, so next thing is that here now, so as I said that cos of phi is equal to 0.6. Okay, which is given to us. Okay, so here this means sin of phi is equal to 0.8. Okay, sin of phi is equal to 0.8. So I can rewrite that x of L is equal to Z sin phi. Okay, so I am returning this expression from the impedance triangle, from impedance triangle. Okay, so impedance triangle is look like this. This is our resistance R. Okay, and this is our coils reactance, inductive reactance. Okay, JXL, and this is our Z. Okay, and this is the angle which is phi given to us. So from this triangle, I can write that x of L is equal to Z sine phi. Okay, so from this expression, I can calculate the value of XL. Okay, so x of L is equal to now Z. The value of the Z is here 31.83 multiplied by sine phi. So the value of the sine phi is 0.8. Okay, so from here XL is equal to 25.464. Okay, so I have calculated the XL. Okay, this is our XL. Now I need to calculate the value of the inductance. So I know that X of L is equal to 2 pi f of L. Okay, so from here L is equal to x of L divided by 2 pi f. Okay, so let's put the values. So x of L is equal to again 25.464 divided by 2 pi into 50. Okay, so the value of the inductance after solving this expression I get 0.08105 Henry. Okay, so this is our answer. So we have calculated the coil's inductance. So this is the value of the inductance and coil's resistance. Okay, so this is the value of the resistance, which is 19.01. So this is our first answer and this is our second answer. Okay, so this is how we have calculated the value. So thank you very much for watching our video. Please like and subscribe our channel.